Okay, so I'm going to talk about Iceberg, about catalog, about how Lakehouse is actually changing the whole ecosystem. And it's partially going to be what Young-Jin already showed, but my focus is a little bit different. But before jumping into the details, I would like just to emphasize how important is open source. You know, like the whole revolutionary stuff about Iceberg, Lakehouse wouldn't be possible if open source is not going to be here, right? So, and we at Vakamo, it's a company like which I co-founded with Christian. We love open source, and maybe just to understand, I really love to make some kind of a poll. Can you please raise your hand if you use open source? Okay, so almost everyone. Now let's just try another one. Can you raise your hand if you contribute to open source? It's a different picture, but it's quite good picture, I would say. So there are a lot of hands on that one. So that's kind of important thing, guys. Open source lives from a community, so feel free to contribute. And it's not just about to write a code. So it might be like quite difficult just to go and write a code. You can just go and try it out. Write a feedback, open issue, improve some documentation, or even write a documentation. So it's quite helpful to drive the adoption of open source. Well, we are from Vakamo, creators of Lakekeeper. My co-founder is just here, and if you have like a nitty-gritty detail question about the technology, Christian is meant to go and ask about that stuff. In case you have like any questions regarding Lakekeeper and Iceberg and implementation of Iceberg and how you can actually build and migrate to Lakehouse, feel free to reach out to us. You have emails, you have LinkedIn. And I just mentioned open source, and we created open source product as well. It's Lakekeeper. It's on a GitHub, licensed under Apache. And like for everyone who couldn't just raise a hand on a contribution, here's a really easy way. Scan the QR code, start our project, and you're going to be an official contributor to open source. Well, we had a discussion about AI, about data, and and an Iceberg, right? So an Iceberg is quite interesting because if I will just put that into relation, well, actually, data is that thing which drives AI, right? So all that LLM, ML, whatever you take, without data, there is no AI. So the boats and shovels is in the data. But we create our catalog, and that's actually not exactly our focus. So we don't manage data, right? So we don't manage AI. What we manage is metadata, and from what I understood in all my talks, the metadata is actually all around the Iceberg. It's where Iceberg actually swims. So, and that's kind of like very interesting perspective on what we do and how important metadata is, and how metadata was not really in a main stage, in a spotlight, but metadata was very kind of a necessity, what someone needed to do and go and write some information in a wiki page and so on. But we think that we are in a beginning of a new category where metadata can become actionable. But before that, let's just jump to the evolution. So we can just get all that wording correct. We all know the old days data warehouse, and nowadays I meet people that don't even know what data warehouse is. They're just like, oh, I've never tried that. But the older days, like Oracle, Teradata, and all that migration from one system to another, like you started with IBM DB2, then you went to Oracle, then you went to, to Teradata, and then you went back to Oracle Exadata, and then you probably went to Snowflake or whatever. And then all that use cases which cannot be pushed inside of a star schema or Snowflake schema. The community created a big data system, so you can just go and store your Parquet files, your Avro files at mass, at petabytes and exabytes of scale. The main component here for the metadata journey was a Hive meta store. Like in data warehouse, you have information schema that kind of took all that care of the technical metadata. And a big data system, we had Hive Metastore, which created a fast state in front of your files and kind of helped you to work with that data. Well, the guys on the data warehouse said, okay, we need to actually innovate here, and they created a cloud data warehouse, like with two main goals. First of all, it was super easy to run that. With a click of a button, you got your cloud data warehouse, Redshift, Snowflake. And the second thing what they achieved is they distributed compute and storage. So now you can actually store as much as you want inside of a Snowflake, but then you can just provision a warehouse of a size what you actually need for your analytics. Well, data lake was not just sitting around. They said, okay, let's just do on a big data, a data lake, and we invented the object storage like Amazon S3 and Google Store and so on. And we have like the main player here is probably Databricks. Someone will argue maybe it's a Trino with a Starburst. But what they created actually, that the data became kind of independent. So data was, you can move it around, you can take whatever compute you want to. Unfortunately, from a metadata perspective, you could not just go and make a transaction. It was quite difficult to have an asset transaction, because sometimes you need to go in and make an update of your table or schema evolution, which was possible in a cloud data warehouse. And therefore, we've got a Lakehouse. That's kind of a baby from a data warehouse in a Lakehouse, and that was based on open table formats, Delta, Hudi, and Iceberg. And as Yunjin said, Iceberg has won in last year, 2024. There is one main component that you require actually to have if you want to build a lakehouse. And let's just see like the architecture, and you probably saw that already. So you have a data producer, data consumer, the good known SAP, Salesforce, and then you can use the ETL, ELT, CDC, batch, streaming, all the different ways how to load the data. And on the other hand, you have like data consumers. Power BI, Tableau, Jupyter, all the different one who is going to scan the data. And now we have a lakehouse, which contains out of write compute and read compute. And in that situation, you know, like, okay, if I am like a data engineer, I will probably go and install some kind of Spark cluster in a classical way, or maybe Rising Wave, if I want to just get like more power. And then on the other hand, so someone is like, oh, I need to read the data. So then I have my DuckDB, I have my Trino, I have my Snowflake. And they're going to read data from a storage, from a S3, which is a Parquet file. But it's not just a simple Parquet file, that is an Iceberg, which brings the metadata. It's why I was referring to the metadata. But in order to create an Iceberg table, you need a catalog. And Eugene had like the whole list of a catalog. But nowadays, if you're going to build a new lakehouse, you will use REST catalog. You're not going to use JDBC, Hive Metastore, whatever. You will go just to the standard, because having a REST catalog allows you just to use all the different tools, because all the tools just follows the REST specification and allows you actually just to go and read the data. So that's kind of interesting role of Iceberg, and like if you look at Iceberg, you have only two layers, the meta layer and the data layer. The data layer is managed by a storage, it's Parquet or C Afro, or we have a metadata which is managed by catalog. And then you can have like all that write and read compute, and the compute will first of all go to catalog and ask, where is that table? Oh, that table is in Amazon S3, and that's the path, and go and read that Parquet file. And same to write compute. Go and write to that Parquet file. And that's actually where you don't have any bottleneck in that system. So right now, imagine like in all the days you have your Postgres, a monolithical system, and someone just came by and said, okay, let's just decompose the Postgres. The storage of a Postgres became the Amazon S3. The oplock or lock of Postgres became Kafka or Rising Wave. And then we have a compute, which might be like Trino or DuckDB. The last piece of a Postgres was information schema. And that is exactly what catalog is actually doing here in that kind of like scenario. Unfortunately, it's maybe not an appropriate word for a component. So if that would be called like a metastore information schema, it would actually describe that kind of like in a better way. So let me introduce Lakekeeper. Lakekeeper is one of the catalogs. There are different catalogs out there, but we will claim that Lakekeeper is the most independent catalog, which is not biased to any compute engine. It's not providing any opinion like, oh, that's like the best way how to read data. We're just trying to have our Switzerland flag and say like, oh, we are neutral. But we will provide like the best service to whatever technology is out there, if that technology follows the standard. The standard of Iceberg REST. And one of the things is what catalog manages is the life cycle of a table. So if you have your DDL and you would like just to create table, drop table, alter table, that's what catalog was made for. In the meantime, we have like an additional requirement from a market, because you see the whole zoo, right? So you see like all that query engines, you see all that storages, and that's just a single company where you have hybrid multi-cloud scenario, and then you have like someone who is in e-commerce uses Kafka, someone from sales uses DuckDB, and so on and so forth, and that's just in a single company. And then there's a guy from data security is asking, so how should I just go to everyone and say who is reading and who is writing from which system? It's not possible, and therefore the question was raised, okay, we have a central system which manages life cycle of a table, so why not to manage that system, the access governance? And that's how we got to the fine-grained access control within catalog. And our concept is to use the Google Zanzibar paper and system named OpenFGA, which is the open source system from Okta, and that allows you to use a relational-based access control. And the last thing, what we actually making some innovation is the computational governance, because what we have a metadata, and if metadata will become actionable, we can do some very interesting stuff which was not possible before that. So we are written in Rust as well. So we are fast, we are lightweight, we are Kubernetes native. It's super easy just to use us. We just trying to eliminate all friction. So you have like a Helm chart, you go and then just deploy everything, and you have like all in a single namespace. It's a single binary. If you would like to play around, just go to the GitHub. There is a folder examples, and just with a simple Docker Compose app, you can just get the whole scenario up and running. We created Lakekeeper modular and extendable. So right now we have OpenFGA as our authorization component, but if you would like to use LDAP, you can just go and take that module and rewrite that for LDAP and just get that to Lakekeeper. So it's not bundled, it's not monolithical in that sense. It's very easy just to extend and to change. And, well, we are Apache 2.0, so feel free to contribute. We are open for the contribution. Well, a catalog is one thing, but if you have your Iceberg table and you're kind of happy on day one that you will just say, okay, I created the Iceberg table, now I can go and read that Iceberg table. On day two, you're going to be quite unhappy because you will load a lot of small Parquet files. You will going to change your manifest files, your metadata of that Iceberg table, and that's going to have an impact on performance. Because now you need just to go and open like 100 different Parquet files just to read and understand, do I need to open that Parquet file? So a lot of I/O on that side. To keep actually the whole table in a shape, you need to run the maintenance. And there are different tasks. And let's say the metadata maintenance is quite simple, but then you need to go and make a vacuum on your table. So you need to say, okay, after 30 days, I would like just to delete all history of my table because it costs too much money to store the data. And the most tricky is the compaction. And if everyone is just, or someone of you looks for a kind of a challenge, compaction is quite interesting challenge, and especially compaction with Iceberg based on Rust is the most interesting part, because a lot of companies and startups trying to innovate in that space. So you probably can contribute here as well. So let's start with fine-grained access control. So we have our Lakekeeper, and we are producing, and we're using like Kubernetes. And then to load data, you will take whatever technology. Let's say you have your use case, you would like to run your batch jobs. And for that, you will use a general compute. And that general compute is going to use a client ID and client secret from your IDP. It's not going to use any access key and secret key from your storage. You don't need to bother with that anymore. When you create a new warehouse inside of Lakekeeper for Iceberg, you will just tell, okay, here's exactly your access key and secret key, and catalog is going to take care to vent credentials to every client or sign URLs. So that's super easy, just implemented inside of catalog. So you as a client, You don't need to go and ask your CISO, can you give me the access to that specific bucket? It's all provided and managed by Catalog. And inside of Catalog, we can say, okay, that's that user from Spark, he can just go and write to table customer, it's all good. But then there's a challenge. You have your multi-user system, such as a Trino. And that Trino will connect again with that specific technical user. But then you have hundreds or thousands different users. And then you will say, okay, I have a Peter who should read and write. And then I have a user Anna. Well, probably, maybe just only this one table. And this is what you can actually do with Lakekeeper, because we built a specific implementation here for that, where we still use our OpenFGA, where we're going to store the tuple, like user, object, and action. But that Trino now can communicate with Lakekeeper. We built the so-called Open Policy Agent Bridge. And with that bridge, you can actually go and use Trino as a multi-user system. And with the way that the connection is going to your IDP. It can be Keycloak, Okta, Entra ID. And those IDPs will issue the token. And with that token, we will know that that's a user. And for that specific user, we can go through the Open Policy Agent and understand that that is a different user. So which means here you can see actually, well, a cutting-edge, enterprise-ready, open source Lakehouse. So everything what you hear from Databricks or Snowflake, you can build that by yourselves if you want. Well, I planned actually the demo, but because we are kind of running out of time, I will just jump over. So if someone is kind of interested to see a demo, feel free to reach out to me. I'm happy to jump on a call and show you exactly the demo on how you can use Trino in multi-user setup, that you can have like Peter who will write and Anna who can just read. It's all possible, and it's super interesting to see, which kind of like a very boring thing, but it's very hard to do that in a distributed world. So what I would like actually to move on is to the topic on computational governance, and we have change events. And what is a change event? So if you run the alter table, and that is a metadata change, which means we're going to do some change on table without making any change on data, maybe. We just want to rename a field. But Lakekeeper is capable of to push that information to a Kafka topic or to a NUTS messaging queue. And then you can think about all the different systems. So let's say, oh, you would like to write an audit system or fraud detection or quality type of a system. So someone just went and renamed the field, which is not exactly how we should call the field. And there are endless opportunities here. And actually why? Why it's so important? You know, like if you look at last 20 years, data was actionable. So customer was on a website, or let's send him an email with a discount. Or customer used a discount, let's send him even more newsletters. So all on the data. But at the same time, everyone was complaining, quality is not good. The ownership, I don't know who uses that table. You know, like there's a Jon Snow, let's go to John and ask him. Well, John left the company for 12 months. We have no idea. The results are outdated. Statistics are not good, and so on and so forth. And the answer is not in the data. The answer to solve that challenge is in metadata. And unfortunately, metadata was, as I said, a necessity. No one was really taking care on the technical metadata. But with a catalog, we can actually do that metadata is going to be actionable. And let me just show you one of the examples what we are right now working on. And that's kind of a huge problem. And maybe one of you will see yourself in that challenge. So we have a Lakekeeper and we have a data engineer, like owner of a customer table. Let's assume from a marketing department. And that person is going to write data to customer table. And then we have a guy, a poor guy, analyst from a sales department who built a report and relies on the data because he or she needs to go to a manager and show some numbers that they're going to make a business decision, which is to make money inside of a company, to generate revenue, to save some cost, and so on. So really business decisions. So what our data engineer can do, because role-based access control allows to do so, can just go and rename a field. And that will just break the report of a sales guy. And you know, when that happens, usually it's like Monday, 9 a.m. when you need actually to prepare your report, go to manager, and your report doesn't work. So you cannot make a business decision, you cannot make money, you have a real impact on your business. So how can we solve the problem? Because we have that control on the metadata, and we can make the metadata actionable, we can actually create a data contract engine where the data contract is not going to be a document like a PDF, it's going to be a computational unit and will contain some SLOs, stable schema, for instance. So what Lakekeeper is going to do is going to just go and check, well, data engineer, you would like to change the customer table, but you have a consumer here with a relationship, and we're going to enforce that because there is a stable schema, and data engineer will get a conflict. You cannot change that. So the role-based access control allows you to do so because you're the owner, but you have a constraint on the business side which prohibits you to do. So that's a different type of a governance. It's a computational governance to keep the whole system stable, or as Christian says, unbreakable. What in that situation can be done, because we have that relationship in that space, so we can just go and say, okay, data engineer will go and churn the contract with analyst, give a grace period of 7 days, adjust to the new type of a schema, because I'm not able to provide that anymore any soon. And that's kind of the way how the system can actually work and automate on metadata. And we heard about AI, agentic system, operators. So just think for a second, there is no human more. There are different AI agents that need that type of automation. And that's exactly how we can provide that. And we can provide that preventive. Not like, okay, someone is going through the data lineage, just a poor support guy to understand like what happened, why that report doesn't work anymore. We on a place to keep that in control. And that's how we call that new category the actionable metadata, where we can actually document, we can all that relationship between data producers and data consumer, where we can enforce specific contracts and SLOs, because you're going to build all of that data products, and you need a different way how to enforce stuff. And the whole idea is just to secure the collaboration, to make that stable, so you can just use data sharing. And it can be within a company, it can be in a kind of partner network, because we all live in a supply chains. And imagine like an automotive, pharmaceutical, you need somehow go and share your data products and keep control on whatever is sharing here. Well, I will pause here because it's already late. I would love to get you here and contribute to us. Go to GitHub, give us a star. Thank you very much. And if there are any questions, go ahead.